Hello, let's read more. I start to get tired, so I like to go to my bed. I think the Zoom is on, and I have two videos I need to put public, but we can do later. Yes, I like to read this. Nice Airbus 400M. Then I like to make a video about it in my language, Danish.
Airbus A400M Atlas. The Airbus A400M Atlas is a European four-engine turboprop military transport aircraft. It was designed by Airbus Military, now Airbus Defence and Space, as a tactical airlifter with strategic capabilities to replace older transport aircraft, such as the Transall C-160 and the Lockheed C-130 Hercules. The A400M is sized between the C-130 and the Boeing C-17 Globemaster III. It can carry heavier loads than the C-130 and can use rough landing strips. In addition to its transport capabilities, the A400M can perform aerial refueling and medical evacuation when fitted with appropriate equipment. The A400M's maiden flight, originally planned for 2008, took place on the 11th of December, 2009 from Seville Airport, Spain. Between 2009 and 2010, the A400M faced cancellation as a result of development program delays and cost overruns. However, the customer nations chose to maintain their support for the project. A total of 174 A400M aircraft had been ordered by 8 nations by July 2011. In March 2013, the A400M received European Aviation Safety Agency (EASA) certification. The first aircraft was delivered to the French Air Force in August 2013. Development, edit. Origins, edit. The project has its origins in the Future International Military Airlifter (FIMA) group, established in 1982 as a joint venture between Aerospatiale, British Aerospace, BAE, Lockheed, and Messerschmitt Bölkow Blohm, MBB, with the goal of developing a replacement for both the C-130 Hercules and Transall C-160. Varying requirements and the complications of international politics meant that progress on the initiative was slow. In 1989, Lockheed decided to withdraw from the grouping. Lockheed independently developed an upgraded Hercules, the C-130J Super Hercules. With the addition of Alenia of Italy and CASA of Spain, the FIMA group became Euroflag. Project management evaluated twin and quad turbofan engine configurations, a quad propfan configuration, and a quad turboprop configuration, eventually settling on the turboprop option. Since no existing turboprop engine in the Western world was powerful enough to reach the projected cruise speed of Mach 0.72, a new engine design was required. Originally, the Snecma M138 turboprop, based on the M88 turbofan core, was selected, but this power plant was found to be incapable of satisfying the requirements. In April 2002, Airbus Military issued a new request for proposal, RFP, which Pratt & Whitney Canada with the PW180 and Europrop International answered. In May 2003, Airbus Military selected the Europrop TP400D6. United Technologies alleged that the selection was a result of political interference. A Europrop partner executive said in April 2003 that Airbus was close to selecting the P&WC offer, claiming it was more than 400 million euros, US dollar 436.7 million, cheaper than Europrop's bid. As the original deadline for the engine decision passed, Airbus CEO Noel Forget said P&WC's bid was nearly 20% less expensive and declared that as of today Pratt & Whitney is the winner without doubt. A much lower offer could make us change our minds, inviting Europrop to revise its offering, which it reportedly reduced in price by 10 or 20%. A later report described the revised bid as exceeding P&WC's bid by 120 million euros. The original partner nations were France, Germany, Italy, Spain, the United Kingdom, Turkey, Belgium, and Luxembourg. These nations decided to charge the Organization for Joint Armament Cooperation, ACAR, with the management of the acquisition of the A400M. Following the withdrawal of Italy and revision of procurement totals, the revised requirement was for 180 aircraft. The first flight was forecast to occur in 2008 and the first delivery in 2009. In April 2005, South Africa joined the program, with the Denel Saab Aerostructures receiving a contract for fuselage components. Malaysia is the second country outside Europe to be involved. Malaysia through CTRM is responsible for manufacturing composite aero components for the aircraft. The A400M is positioned as an intermediate size and range between the Lockheed C-130 and the Boeing C-17, carrying cargo too large or too heavy for the C-130, while able to use rough landing strips. Delays and problems, edit. In January 2009, EADS announced that the first delivery was postponed from 2009 until at least 2012, and indicated that it wanted to renegotiate. EADS maintained the first deliveries would begin 3 years after the first flight. In January 2009, Financial Times Deutschland reported that the A400M was overweight by 12 tons and may not meet a key performance requirement, the ability to airlift 32 tons. Sources told FTD that it could only lift 29 tons, insufficient to carry an infantry fighting vehicle like the Puma. In response to the report, the chief of the German Air Force stated, "That is a disastrous development and could delay deliveries to the German Air Force, Luftwaffe, until 2014. The initial operational capability, IOC, for the Luftwaffe was later delayed and alternatives, such as a higher integration of European airlift capabilities, were studied." On the 29th of March, 2009, Airbus CEO Tom Enders told Der Spiegel that the program may be abandoned without changes. ACAR reminded participating countries that they could terminate the contract before the 31st of March, 2009. In April 2009, the South African Air Force announced that it was considering alternatives to the A400M due to delays and increased cost. On the 5th of November, 2009, South Africa announced the order's cancellation. On the 12th of June, the New York Times reported that Germany and France had delayed a decision whether to cancel their orders for 6 months while the UK planned to decide in late June. The NYT also quoted a report to the French Senate from February 2009, noting, "The A400M is €5 billion over budget, 3 to 4 years behind schedule, and aerospace experts estimate it is also costing Airbus between €1 billion and €1.5 billion a year." In 2009, Airbus acknowledged that the program was expected to lose at least €2.4 billion and could not break even without export sales. A PricewaterhouseCoopers audit projected that it would run €11.2 billion over budget, and that corrective measures would result in an overrun of €7.6 billion. On the 24th of July, 2009, the 7 European nations announced that the program would proceed and formed a joint procurement agency to renegotiate the contract. On the 9th of December, 2009, the Financial Times reported that Airbus requested an additional €5 billion subsidy. In January 2010, Airbus repeated that the A400M may be scrapped, costing it €5.7 billion unless €5.3 billion was added by partner governments. Delays had already increased its budget by 25%. Airbus executives reportedly regarded the A400M as competing for resources with the A380 and A350XWB programs. In June 2009, Lockheed Martin said that both the UK and France had requested details on the C-130J as an alternative to the A400M. In 2011, the ADS Group warned that shifting British orders to American aircraft for short-term savings would cost more in missed business, stating that A400M technologies would be a bridge to a new generation of civil aircraft. In November 2010, Belgium, Britain, France, Germany, Luxembourg, Spain and Turkey finalized the contract and agreed to lend Airbus military €1.5 billion. The program was then at least 3 years behind schedule. The UK reduced its order from 25 to 22 aircraft and Germany from 60 to 53, decreasing the total order from 180 to 170. In 2013, France's budget for 50 aircraft was €8.9 billion, $11.7 billion, at a unit cost of €152.4 million, $200M, or €178 million, $235M, including development costs. The 2013 French White Paper on Defense and National Security cut the tactical transport aircraft requirement from 70 to 50. As the A400M was unable to perform helicopter in-flight refueling, France announced in 2016 that it would purchase 4 C-130JS. In July 2016, French aerospace laboratory owner confirmed successful wind tunnel trials of a 36.5 m, 120 feet, hose and drop configuration that permits helicopter refueling. Prior tests found instability in the intended 24 m, 80 feet, hose due to vortices generated by the spoilers, deployed to achieve 108 to 130 kT airspeed. On the 1st of April, 2016, ADS stated it was addressing production faults affecting 14 propeller gearboxes, PGBs, produced by Italian supplier Avio Aero in early 2015. The issue, involving a heat treatment process that weakened the ring gear, affected no other PGBs. The units involved needed changing. Airbus noted, pending full replacement of the batch, any aircraft can continue to fly with no more than one affected propeller gearbox installed and is subject to continuing inspections. Another PGB issue involved input pinion plug cracking, which could release small metallic particles into the oil system, which is safeguarded by a magnetic sensor. Only engines 1 and 3, which have propellers that rotate to the right, were affected. The European Aviation Safety Agency, EASA, issued an airworthiness directive mandating immediate on-wing inspection, followed by replacement if evidence of damage is found. On the 27th of April, 2016, Airbus warned there may be a substantial PGB repair cost. An interim PGB fix was certified in July 2016, greatly extending inspection intervals. In May 2016, Airbus confirmed that a cracking behavior identified during quality control checks in 2011 was found in a French A400M fuselage part. Not impacting safety, it could be repaired during regular maintenance forward/upgrade schedules. The aluminium zinc alloy, known as 7000 series, was used in several central frames. Its chemistry, along with environmental conditions, led to crack propagation. The alloy was excluded from future aircraft. A retrofit to remove it from earlier 400MS was considered, which could take up to 7 months. On the 29th of May 2016, Enders conceded in an interview published in Bildungssonntag that some of the massive problems of the A400M were of Airbus' own making. We underestimated the engine problems. Airbus had let itself be persuaded by some well-known European leaders into using an engine made by an inexperienced consortium. Furthermore, it had assumed full responsibility for the engine. On the 27th of July 2016, Airbus confirmed that it took a $1 billion charge over delivery issues and export prospects. Enders stated, industrial efficiency and the stepwise introduction of the A400MS military functionalities are still lagging behind schedule and remain challenging. Flight testing, edit. Before the first flight, required airborne test time on the Europrop TP400 engine was gained using AC-130 test aircraft, which first flew on the 17th of December 2008. On the 11th of December 2009, the A400MS maiden flight was carried out from Seville. In April 2010, the second A400M made its first flight. In July 2010, the third A400M took to the air, at which point the fleet had flown 400 hours over more than 100 flights. In July 2010, the A400M passed ultimate load testing of the wing. In October 2010, Airbus announced the start of refueling and airdrop tests. By October 2010, the A400M had flown 672 hours of the 2,700 hours expected to reach certification. In November 2010, the first paratroop jumps were performed. Enders and A400M project manager Bruno Delanoy were among the skydivers. In late 2010, simulated icing tests were performed on the MSN-1 flight test aircraft using devices installed on the wing's leading edges. These revealed an aerodynamic issue causing horizontal tail buffeting, resolved via a 6-week retrofit to install anti-icing equipment fed with bleed air. Production aircraft are similarly fitted. Winter tests were done in Kiruna, Sweden in February 2011. In March 2012, high-altitude start and landing tests were performed at La Paz at 4,061.5 m, 13,325 feet, and Cochabamba at 2,548 m, 8,360 feet, in Bolivia. By April 2011, a total of 1,400 flight hours over 450 flights had been achieved. In May 2011, the TP400D6 engine received certification from the EASA. In May 2011, the A400M fleet had totaled 1,600 hours over 500 flights. By September 2011, the total increased to 2,100 hours and 684 flights. Due to a gearbox problem, an A400M was shown on static display instead of a flight demonstration at the 2011 Paris Air Show. By October 2011, The total flight hours had reached 2,380 over 784 flights. In May 2012, the MSN-2 flight test aircraft was due to spend a week conducting unpaved runway trials on a grass strip at Cottbus-Druitz Airport in Germany. Testing was cut short on the 23rd of May, when, during a rejected takeoff test, the left side main wheels broke through the runway surface. Airbus military stated that it found the aircraft's behavior was excellent. The undamaged aircraft returned to Toulouse. At the 2012 Royal International Air Tattoo, the aircraft was officially named Atlas. In March 2013, the A400M was granted type certification by the EASA, clearing its entry to service. Production and delivery, edit. Assembly of the first A400M began at the Seville plant of EADS Spain in early 2007. Major assemblies built at other facilities abroad were brought to the Seville facility by Airbus Beluga transporters. In February 2008, 4 Europrop TP400D6 flight test engines were delivered for the first A400M. Static structural testing of a test airframe began in March 2008 in Spain. By 2010, Airbus planned to manufacture 30 aircraft per year. The Turkish partner, Turkish Aerospace Industries, delivered the first A400M component to Bremen in 2007. The first flight, originally scheduled for early 2008, was postponed due to delays and financial pressures. EADS announced in January 2008 that engine issues had been responsible for the delay. The rescheduled first flight, set for July 2008, was again postponed. Civil certification under EASA CS25 was followed by certification for military uses. In June 2008, the A400M was rolled out in Seville at an event presided by King Juan Carlos I of Spain. On the 12th of January 2011, serial production began. In August 2013, the first A400M was delivered to the French Air Force. It was formally handed over during a ceremony in September 2013. In August 2013, the first Turkish A400M conducted its maiden flight from Seville. In March 2015, Malaysia received its first A400M. In May 2015, it was revealed that the member nations had created a Program Monitoring Team, PMT, to review and monitor progress in the A400M's development and production. The PMT inspects the final assembly line in Seville and other production sites. Early conclusions observed that Airbus lacked an integrated approach to production, development and retrofits, treating these as separate programs. On the 9th of May 2015, an A400M crashed in Seville on its first test flight. Germany, Malaysia, Turkey and UK suspended flights during the investigation. Initial focus was on whether the crash was caused by new fuel supply management software for trimming the fuel tanks to enable certain maneuvers. Airbus issued an update instructing operators to inspect all engine control units, ECUs. A key scenario examined by investigators is that the torque calibration parameter data was accidentally wiped on 3 engines during software installation, preventing FADEC operations. On the 3rd of June 2015, Airbus announced that investigators had confirmed that engines 1, 2 and 3 experienced power frozen after liftoff and did not respond to the crew's attempts to control the power setting in the normal way. On the 11th of June 2015, Spain's Ministry of Defense announced that prototypes could restart test flights and that further permits could be granted soon. The RAF lifted its suspension on A400M flights on the 16th of June, 2015, followed the next day by the Turkish Air Force. On the 19th of June, 2015, deliveries restarted. In June 2016, the French Air Force accepted its ninth A400M, the first capable of conducting tactical tasks such as airdropping supplies. The revised standard includes the addition of cockpit armor and defensive aid system equipment, plus clearance to transfer and receive fuel in flight. Design, edit. The Airbus A400M provides substantial improvements to payload, range, internal volume and operational capacity over the Transall C-160 and Lockheed C-130 that it replaces or augments. It can carry up to 37 metric tons, 41 short tons, over 2,000 mi, 3,700 kilometers, 2,300 mi. The cargo box is 17.71 m, 58.1 feet, long excluding ramp, 4.00 m, 13.12 feet, wide, and 3.85 m, 12.6 feet, high, or 4.00 m, 13.12 feet, aft of the wing, and can be configured to transport cargo, military personnel, drop paratroops, conduct medical evacuations or carry out aerial refueling. It can operate out of short, soft landing strips and fly long-range cargo. A typical cargo load might include 6 Land Rovers and their trailers, or 2 light armored vehicles, or a dump truck and excavator, or a Patriot missile system, or a Puma or Cougar helicopter, or a truck and 25-ton trailer. It features a fly-by-wire flight control system with side stick controllers and flight envelope protection. Like other Airbus aircraft, the A400M has a full glass cockpit. Most systems are loosely based on those of the A380, but modified for the military mission. The hydraulic system has dual 207 bar, 3000 side channels powering the primary and secondary flight control actuators, landing gear, wheel brakes, cargo door and optional hose and drag refueling system. As with the A380, there is no third hydraulic system. Instead, there are 2 electrical systems. One is a set of dual-channel electrically powered hydraulic actuators, the other an array of electrically forward/hydraulically powered hybrid actuators. The dissimilar redundancy provides more protection against battle damage. More than 30% of the airplane's structure is made of composite materials. The 42.4 m, 139 feet, span wing is primarily made of carbon fiber reinforced plastic components, including the wing spars, the 19 m, 62 feet, long, 12-14 mm, 0.47 0.55 in, thick wing skins, and other parts. The wing weighs about 6,500 kilograms, 14,330 pounds, and it can carry and lift up to 25,000 kilograms, 55,116 pounds, of fuel. It has an aspect ratio of 8.1, a wide chord of 5.6 m, 18 feet, and a sweep angle of 15 degrees at 25% mean aerodynamic chord. The A400M has a T-tail empennage. Its vertical stabilizer is 8.02 m, 26.3 feet, tall. The horizontal stabilizer spans 19.03 m, 62.4 feet, with a sweep of 32.5 degrees. A Hamilton Sunstrand propeller for the A400M at the Paris Air Show, 2009. The Ratia Fijic FH385 propellers turn counterclockwise and the FH386 clockwise. The 8-blade scimitar propellers are made from a woven composite material. It is powered by 4 Europrop TP400D6 engines rated at 8,250 kilowatts, 11,000 HP, each. The TP400D6 engine is the most powerful turboprop engine in the West to enter operational use. The pair of propellers on each wing turn in opposite directions, with the tips of the propellers advancing from above towards the midpoint between the two engines. This is in contrast to the overwhelming majority of multi-engine propeller-driven aircraft where all propellers turn in the same direction. The counter-rotation is achieved by the use of a gearbox fitted to two of the engines, and only the propeller turns in the opposite direction. All four engines